So our lecture number 2 is about floating point. So as you can remember in your decimal number, we have what you call your exponential point representation. So we have this general notation of an exponential point, but this one is a general notation for base R. So remember, this is in your decimal exponential form, we have this value, your decimal whole number, and this is the base of your decimal, which is usually equals to 10, and this is your exponent. So your B is the base of your floating point number system. If we are in a binary, we are using the ECE 754. So in your ECE 754, your M is a mantissa of 24 bits, and your E is an exponent of an 8 bits. So for your exponent, we have two types. We have the unsigned and signed exponent. For signed exponent, your range is from 0 up to 255 because it is an 8 bits. But if it is signed exponent, for an exponent of 0, if we have an exponent of 0, your initial value of your exponent is 127, or that is equivalent to 0, 1, 1, 1, 1, 1, 1, and 1. So if we have this one as an exponent, it represents that your exponent is 0. So we have this example. So for example, we have 25 decimal. We have to change this one into a floating point. So first, you have to convert decimal into binary. So this is our binary equivalent of 25. Then if we have to use your general exponential notation, so we have this notation as 1.1001 by 2 to the 4. So why it is 4? Because we move your decimal or your binary point from this side going to left side, and there are 4 bits that we have. So that's why we have an exponent of 4. So this is your general notation. Then if we have to change this one into a floating point using ECE 754, so first we have to get your exponent, which is equivalent to 127 as the exponent of 0, then plus 4, then we have 131. Change that 131 into binary, so this is the binary of your 131. And your mantissa, so in your mantissa, since 1 is always constant in our binary floating point because there is no other value except for 1 if we have a scientific notation. So this is constant. So therefore, your mantissa will be the value after your binary point. So since it is 24 bits, so we have the first 4, which is to represent this one, and the remaining bits will be all 0. And you must have a 24 bits all in all. But the beginning value will be the value of your scientific notation after your binary points. Then if it is fraction, so we have this one, 0.1275 to binary floating point. So we have to change this fraction, your decimal, into binary. So the binary equivalent for this one is this one. So we extended for another one. Usually we end up to 6 digit. But if your 6 digit or 6 bit is 0, so we have 1, 2, 3, 4, 5, 6. Since this is 0, we proceed to another value so that we can get a whole number. So this is 1. But we have to proceed to another one for your scientific notation na ay decimal or demarcation point. So if we have to represent that one into a scientific notation. So that is equivalent to 1.1 times 2 or by 2 to -7, because from this point up to this value, to this decimal point, that is, there are 7 bits from your right side going from left side going to your right side. Then we have to change your exponent. Exponent of 0 is 127 minus 7, that is 120. And we have to change 120 into binary. So this is 120 in binary. And your mantisa is equals to 1, then 23 ka 0 ang mosunod. Since your exponential or scientific notation is 0.1, so this is part of your mantisa as your leading bit in your mantisa. And that is all for floating point.